In this video, we are going to focus on chapter 4 of polynomials and partial fractions, focusing on the skill of how do we express proper or improper algebraic fractions in its partial fractions. So based on what we have covered in the notes, we know that in order to express any algebraic fraction as the sum of its partial fractions, we have three main steps. Step 1, we check that whether the given fraction here is proper or not. So if it's proper, it means that, recap, a proper fraction means degree of numerator is less than, strictly less than the degree of denominator. So you simply need to find what's the highest power of both your numerator and denominator. And if the degree of your numerator is strictly less than the degree of the denominator, this is a proper fraction. Otherwise, it is considered an improper fraction. Then we need to use the division algorithm to express it as a sum of a proper fraction and a polynomial. Okay, once done, once we have a proper algebraic fraction, so we can only move on to step 2 once I have a proper algebraic fraction. Then I'll use this table below. Okay, I must first check whether the denominator has been factorized completely first. Then after that, I'll use this table here to perform my partial fraction decomposition, meaning that I'll turn my proper fraction, there's three forms, form 1, form 2, or form 1, form 2, or form 3, into this partial fractions accordingly. So we must first analyze what is in the denominator first. If the denominator has distinct linear factors, linear factor meaning that the power of x is equal to 1, then I can simply write all my linear denominator, the factors, into its partial fraction as such. So the examples here show you, if let's say I have a distinct linear factor, in this case I have two distinct linear factor, I can simply just write a over x plus 3 plus b over x minus 2. If I have repeated linear factor, meaning that I have the same factor square, okay, I will turn it into the factor power 1 first, and then plus the factor power 2. So in this case over here, if I have x plus 3, the whole thing square, this will become x plus 3, a over x plus 3 plus b over x plus 3, the whole thing square. Okay, and the last one, irreducible quadratic factor. If I see that the denominator cannot be factorized anymore, then after that, I'll write it as ax plus b over the irreducible quadratic factor. So for example, let's say if I have these two factors over here. One is a linear factor, x plus 1, so I have a constant over x plus 1. Whereas over here, I have x squared plus 2. X squared plus 2 cannot be factorized any further. This is not x squared minus 2, it is x squared plus 2. Therefore, I have to convert it to the form of ax plus b over x squared plus 2. Okay, so very important over here, this is the linear factor. This is the irreducible. Irreducible also means the same thing as unfactorizable, cannot be factorized. Irreducible quadratic factor, meaning that the power of x here must be equals to 2. Okay, so there are three main forms. You need to be able to identify from your denominator of your proper fraction which of the correct form should you convert your given proper fraction into. Okay, so then after that, once we're done so, you need to make sure that you write that a, b, and c, all these are constants to be found. And in the last step, you will simply substitute values of x or equate coefficients to find out the constants, all these constants that you wrote over here, which is a, b, and even c, for example. Okay, so let's look at one very important fact first. If we recall from what we have learned in the division algorithm, any polynomial can be written in this form, whereby I have a divisor times the quotient plus remainder. But actually, I can also rewrite it in another form. Let's say if I have this fx here divided by this divisor gx. If I use my long division, I can also rewrite this to be quotient plus the remainder over the divisor. So let's look at this in proper action. Example 1, okay? Express this fraction here in its partial fraction. So we go back to the steps of how do we do partial fraction decomposition. Step 1, we first check whether this given fraction here is proper or improper. So if you analyze this, you notice that the degree of my numerator here is equal to 2, because the highest power here is 2. And the degree of my denominator here is also 2, because the highest power is 2. So therefore, since both are 2, therefore this is an improper fraction, because for a proper fraction, the degree of the numerator must be strictly less than the degree of the denominator. So because if it's proper, we move on to step 2. But because if it's improper, we must use the division algorithm in order to obtain a proper fraction. Okay. Then after that, once we've done that, step number 2 is to check that denominator has been factorized completely. Apply partial fraction decomposition. Then last step is to find the values of your constants a and b. So let's look at step 1 first. Okay, step 1, we will use the division algorithm, which is something that you would have learned. So very quickly, I'll show you the answer to this. Okay, if I apply the division algorithm, you'll notice that this is what I'll get based on my division algorithm. So once I've applied my division algorithm based on this fraction over here, I will get this will be my quotient. This is the remainder. So therefore, I can rewrite this original fraction here, which is 3x squared plus 8x plus 1 divided by this divisor here. This can be rewritten as 3x squared plus 8x plus 1 over x squared plus 2x plus 1 can be written as, based on this form over here, quotient plus remainder over divisor. So this will be quotient. Quotient here is 3 plus the remainder, 2x minus 2 over the divisor, which is x squared plus 2x plus 1. Okay, and you notice that once I've done this part here, you will get a proper fraction here. And once I've obtained this proper fraction, then I can now move on to my step 2, which is check that the denominator has been factorized completely. So now let's move on to step number 2. Okay, step number 2, I need to check that denominator has been factorized completely. You'll notice that for this part over here, x squared plus 2x plus 1, I can actually factorize this denominator here. So let's do this factorization. Okay, so this factorization here, if we work this out, okay, you actually obtain this following form. Okay, x squared plus, let me shift this. This will be simply this answer here, which is I can obtain this form, okay, by factorizing my denominator. So x squared plus 2x plus 1 can be simply factorized into x plus 1 the whole thing square. Okay, now that I've done that, okay, I check that the denominator here has been factorized completely. Now I can apply my partial fraction decomposition, and this is where the part which we have to memorize from this table here. I look at my denominator and identify which partial fraction do I relate this to. So by observation, you should notice that I will have to apply my repeated linear factor here. Okay, so therefore, simply I can turn this fraction based on what I can observe from the denominator. This will become, I'll now let this fraction here, I focus only on the the proper fraction first. I'll let this proper fraction be equals to this form here, a over x plus 1 plus b over x plus 1 squared, whereby a and b are constants. Then, once I've done this partial fraction decomposition, I can now move to my last step, which is I substitute values of x or equate coefficients to find the values of constants a, b, etc. Okay, so for my first step, before I do this first, I must first get rid of the fraction to make life easier for myself. So let's get rid of this fraction over here. When I get rid of this fraction, I will simply multiply by x plus 1 squared to both the left-hand side as well as the right-hand side. So when I multiply this, x plus 1 squared, I will obtain this equation here. 2x minus 2 equals to a. If I multiply by x plus 1 squared, I will get a times x plus 1 plus b. Okay, and once I've done so, now I can just sub in values of x that will help me find the value of a and b, which are my constants. So over here, if I do substitution, which I think is the faster method, okay, you realize that I can sub x equals to -1 and x equals to 0. I choose x equals to -1 first because I know that -1 plus 1 is equal to 0. And this will help me cancel out this a over here. And I'm left with b. And this will help me easily find what is the value of b. Then once I've obtained the value of b, my next value of x, I can choose any number. Usually I use smaller numbers to help me. And in this case over here, I will choose 0 because here is 2x. So if I choose 0, it will make my life easier by cancelling this thing out as well. So this, when I sub x equals to 0, I'll get negative 2 plus a times 1 plus b, which is from this part here. And then by solving, I'll get a equals to 2. So now that I've solved for my constants a and b, my last step is to rewrite the original equation. Remember, the question says, express this original fraction in this partial fraction. We have found that this original fraction here is equal to 3 plus this proper fraction, which we have decomposed into its partial fraction. So now a lot of students will always forget to include this original 3 over here. So please make sure you check. My last step is to include the original line, and therefore I combine everything together with my a and b constants, and this will be my final answer to the partial fraction question. Okay? So I hope that this video has helped you to understand and to do a recap as well on how do we break down any fraction given into its partial fractions.